GDG Cloud Boston and GDG Atlanta are pleased to present Informal Session number 3 in the series of Professional Cloud Database Engineer Certification Workshops. This is a series of 12 workshops. We're doing one workshop every week throughout the summer, and the goal is to help people get trained on database technology within Google Cloud and also pass the certification exam if that's a goal of yours. We have a lot to cover this evening, but your hosts are Norbert Kremer in Boston. Jessica Rudd is from GDG Atlanta. She will not be joining this evening due to another commitment, but she's often here to help run the sessions. And you can read about our bio sketches on the registration page. I won't go into details other than to say that we have a lot of experience with Google Cloud and with databases, so we feel comfortable leading these sessions for you. All GDG events are covered by Code of Conduct. The spirit of that is very simple. It's just be nice, respectful, collaborative, participate to the extent that you can. And there's a formalized version of that here with a link, and you can read all the legalese version of it, but it's fairly intuitive what we're going for here. So that should be fine. Let's give our overview of what we're going to do. I want to review a couple of interesting things that were in the news this week. So I'll have a little review of what we did, what happened in the last week. Then we'll talk about where we are in our learning path, how we're doing against our plan. This evening, I developed some custom material that I've developed that normally our formal sessions every other week are using materials supplied by Google, and then in these informal sessions like today, I sometimes develop my own material, and that's what I have this evening. So I have some interesting topics to go into. One of those is the history of relational databases. So we're pivoting now. We've had a lot of discussion about relational databases so far, and we're getting now into the next courses are Cloud Spanner and Bigtable. And Cloud Spanner is still in the group of relational DBMS, although it's a very special one, very unique, has some unique capabilities that we'll talk about. And then when we get into Bigtable, then we're clearly out of the realm of relational databases and we're into the so-called NoSQL area. And so this evening I'll talk about the history of relational databases and some of the properties that distinguish relational databases from others. And then I want to give you a section called Working with Databases, which is to take a look at a few tools that are not really part of Google Cloud, but there are tools that you might want to use with Google Cloud databases or with on-premises databases. And some of these you may know about, and others are, I think, quite useful. And I can explain to you how I install them and the joy I had last week of doing that. It was quite a learning experience. And then we'll wrap up with some Q&A and take a look toward next week, what we're going to do next week. So let's get going. Let's review some news events last week. So I want to mention the CrowdStrike software update because we've it's not really a database specific issue, but the CrowdStrike itself was not really in the cloud. It was affecting many servers across, I guess some were in the cloud, but many were not in the cloud. So it's not really a cloud-wide outage, but it's similar to the very rare instances when all of Google has gone down or all of AWS or all of Azure have just become unavailable for usually a short period of time. And it's interesting to explore some of the reasons for why that happens. And we don't know all the details yet of what happened with CrowdStrike. I think that's going to be emerging. It was a fairly serious disruption economically to airline industry and healthcare industry, especially in the U.S. and probably elsewhere as well. Globally, I'm sure there were other impacts. But so these things tend to be investigated. And I know with some of the Google outages, the investigation shows somewhat like when there's an airliner crash, that it's a combination of many rare events that come together. So there's all these unlikely things happen, and they all happen at the same time in the same moment, and that leads to a bigger problem, or a airline crash or something like this. So I think just to put this in the context of what we've talked about in our courses here, it looks like their deployment plan was neither canary nor blue-green deployment. Okay, so we talked about canary deployment plan where you release new code to a small set of servers and make sure everything's running well and no problems are discovered, and then you start rolling it out gradually to more and more, and then that's called canary approach. Blue-green is a rapid cutover, but you retain the old system so that you can jump back to it if need be. Now, in this case, they weren't able to do that because apparently, whatever the details of this were, it caused a problem. And I'm thinking particularly of the Windows servers that got impacted. They replaced some file on the Windows server that caused a restart. And so it would essentially restart the server and then immediately stop and restart again. It would just go into a restart loop, basically. And that could not be fixed remotely is the big problem. And so people had to actually physically go to all of those servers. And if those servers are in a co-location hosting facility or in the cloud, that's really problematic. So that was part of the issue, and I just want to call it out for what it is. I'm sure there will be a lot of investigation over this because of the economic impact, and it's not just it's not just IT anymore. It's really affecting a very large number of people. I want to call out one other incident that happened last year, this in 23, the so-called FAA system outage, which was caused by the NOTAM database, which is used to notify pilots of important events that might impact their flight paths or their travel plans. And it could be severe weather or other situations that pilots need to know about. So the FAA has this NOTAM, so-called NOTAM database, and this was caused by damaged file being put into the place of a good file, and then it seemed that there, in the NOTAM, there was some connection to database replication. So there was a primary and a backup, and somehow things got messed up and the database synchronization was not happening. So that caused the system to not accept any more updates. So I think people were just getting a static view without getting the NOTAM alerts, and therefore at a certain point the FAA grounded all flights and caused a big problem. So yeah, I'm watching the Slack, the chat. I'm watching the chat, but only intermittently. So if something is really urgent, please open your mic and call out, because I can't watch I can't watch it too closely. I just think these are really interesting. I noticed none of the cloud vendors really make, in other words, they don't call out other companies usually for these failures, because I think there's this feeling that we all live in a glass house, and I think every major cloud provider has had a severe issue at one time or another, and so nobody wants to really make that a selling point, because it just makes the perception is that the cloud then is unsafe in general, and people don't remember, oh, that was, that was a Google issue or that was a Azure issue. They just remember, oh, the cloud is not reliable, and that's the last thing that they want to do. So that's, yeah, so I think we'll, what I've heard about the CrowdStrike thing was that it was some kind of a null pointer exception was not caught, which is a Java error. And that is, some people have said that that's a rookie mistake, so it's not clear how that got through the QA plan. And then also there was a question of whether Microsoft should have caught this error themselves before it got deployed widely to their Windows servers. So anyway, that's all very interesting. Let's move on to our relevant material here. I just thought these were interesting observations from this week. So where are we in our plan here? Again, our goal here is to give you a lot of knowledge about how things work theoretically, and then we also translate that into expertise and job role excellence using training on SkillsBoost with a lot of hands-on labs. In fact, we're now at the point in the course, in the learning path, where all of the courses are just labs, pure labs, and we've gone through all the video lessons already, and there won't be any more of those. And so you got to hear me talk about things, and then the labs are there as much as you can run them. And so with that, again, overall our goals are to give you enough breadth so that you know how to choose the best technology, and enough depth so that you know how to use it in the best way possible. In other words, this will help you design solutions and also implement the development of those solutions. Those are the dual goals here of this learning path. And all of this obviously in the database engineering realm. So we looked at the pretty extensive set of labs, and I tried to roughly estimate how many hours of commitment there are to this column here is video. So 12 hours of video lessons total, which we're now well past. And then we had some 65 hours at least of labs. That's if everything goes well on the first try, which it often doesn't, right? So that's kind of the bottom estimate, but at least it gives some rough allocation week by week of where we are. So based on this, and there's a link here, you can link out to this later to look at more details on this point. So we reallocated the available time from the way Google had done it. This is a relatively new learning path, so some of the Google materials were not quite in sync with SkillsBoost. So that's why I decided to make our last formal session was week 5. We had our goal was to complete course 4 and 5, which were the two relational data, the Cloud SQL, two varieties of Cloud SQL, namely MySQL and then Postgres, right? So we finished that last week, and perhaps spilling into this week a bit. So we're actually between week 5 and week 7 on this chart. So we're at week 6, if you will. And everyone should be working on the Spanner course and possibly beginning the Big Table course. And the goal is to substantially wrap those up by our next meeting next Tuesday, and we will have some more detailed discussion about Big Table and what does NoSQL mean and things like that. So that's our overall plan. Let me look at I want to give you perspective on all of the options that are available within Google Cloud. Not every single one is discussed in the learning path and in SkillsBoost. So there's not a lab. There are a couple of products that are interesting and you should know about them, but they're not covered by our labs. And we're going to have some supplemental material in later weeks to cover those so that you have a little bit more than a passing knowledge of what they are. Also mention a couple that Google doesn't offer themselves. but they can be run in Google Cloud through Marketplace. I'll show you how the Marketplace works. Now, remember, I previously mentioned a couple of books that are quite interesting in this area. There's these are not new books. They're about 10 years old or more, but they're still very useful. I'm not sure that there are any better books that have been written more recently, and these are still the ones that I learned from, and they're very good. I mean, they're just very good. This particular one on the left is NoSQL Distilled from Pramod Satellage and Martin Fowler. Martin Fowler, I'm not sure if Satellage worked at ThoughtWorks, but Fowler worked at ThoughtWorks for a long time, and also is a signer of the Agile Manifesto. So very, very important architect in the world of databases. And in this book, they go through and describe 5 or 6 different types of database, and they view each one of them with this idea of called aggregate data model, and it sort of shows how things are stored in each type of database, and that also gives you a good feeling for why these databases were developed in the first place and what the motivations were for building out NoSQL data stores to address some of the limitations of the relational databases. And so I highly recommend this book. This one on the right is more practical and more hands-on. It will step you through how to download the software. Obviously, it's not cloud-oriented. It's the cloud was really pretty nascent in 2012, but if you want to try some things on your local machine, this would be a great place to start as well. Or you could do the same thing in the cloud now, either on a VM or perhaps using a managed service in the cloud. So you could definitely get some great experience from that book as well. As we mentioned previously, there are multiple ways to run a database on Google Cloud. First of all, you can build anything you want on top of a compute engine VM, right? Google Compute Engine VM. You can install your own database software, provide your own license. Everything is self-managed, self-hosted. You're on your own. Many times you can do that same thing within Kubernetes. If you get a containerized version of some database software, you can run that within Kubernetes or GKE, which is a managed Kubernetes service in Google Cloud. So that's always available to you. It's usually preferred if there is a Google Cloud managed service that will do the job for you. That's usually the better way to go. And Cloud SQL, obviously, Spanner, the Google products that you've been working with in the labs are often preferred just because there's that much less toil involved in managing them. There's the patching of security patches and upgrades is managed by Google in the background and just taken off your plate. So that's usually a good way to go. For some other options, there are Google Cloud Marketplace. These are usually pre-made images that you can load into VM, or you can just they really activate as a service, and they're provided by third parties. So they're not really, they're not prepared or built by Google, but they're provided within the Google Cloud Console by third parties. And what's nice about that is that the billing still comes through Google. So you just get one bill. You don't have to engage separately with a vendor to get licensing and all that. And so I think I can jump out quickly. And for those who haven't seen the, let's see, where is I don't know if I can do this quickly. Looks like I can't do it right away. So let me not do that. I was going to show you the marketplace. It's very easy to find it. You just go into inside Google Console, you go into the navigation pane and look for Marketplace, or else go into the search bar within the console and just type Marketplace and you'll find it. And then once you're in Marketplace, you can search for the different products, like use the word database or NoSQL, or if you know the product you want, then you can go right to that and put that in as a search term. As always, with any of these systems that we've talked about, the system architectures are what drive performance and cost characteristics. It sounds obvious when I say it that way, but many people forget this, and they kind of they get confused, or they end up choosing the wrong product, or they end up spending a lot more than they think they should, beyond their budget. And so, again, it is architectures drive performance cost characteristics, and when you're doing solution design, you have to understand those characteristics. You should understand the architecture that underpins that performance, at least to some level. You should understand that architecture. And then you also need to factor in the cost estimates when you're choosing a solution. And we've mentioned previously that some of the Google products have a fairly high minimum cost. They're designed for large scale or operating at scale. So Spanner and Bigtable are two that can have a fairly significant minimum cost just to run the cluster, right? So it's, you might, if you don't think about that, you might say, oh, that's the solution I want. It looks like, I want a NoSQL data store, so why don't I just use Bigtable? But definitely take a look at the cost as well and understand the scalability requirements and the redundancy that's required as well, because you may need a cluster in 2 different AZs or 2 different regions, things like that. So this minimum cost is definitely a factor if you're operating at a smaller scale, which a lot of companies are, not internet scale. Not every company is Yahoo or Google. So let me go back to, right, here we go. So we've already talked about, just the way to read this table is I've grouped them according to the database type, whether it's relational or NoSQL, and these are all the relational ones on this page. Now, the ones that are bolded here on the left are the services that we've actually studied in our courses or will study, right? So we're definitely going to go through, well, we've covered SQL Server on VMs, we've covered the Oracle bare metal solution, as painful as that was, but there we go. What you have when you use those, you have full control over everything, right? Because it's almost self-hosted, right? So you have a lot of control over everything. And then here in the middle, in this middle column, I put what is an on-premises equivalent of the Google Cloud Service. So these are all fairly obvious. Cloud SQL is a managed version of MySQL and Postgres or SQL Server, and those are all relational databases. So this is pretty straightforward. Cloud Spanner is where we really get into something very specialized, because it's globally distributed and horizontal scaling, which almost no other relational database is. In fact, I've said that there's no equivalent on premises. There certainly isn't one on premises. I don't think there's really an exact equivalent in any other cloud provider either. And so the Spanner is really unique, and it's built for scale, both geographic scale and data volume scale, and therefore it does come with this sort of lower, the minimum cost to run it is pretty substantial. So definitely take a look at that. But it's very, very, very capable, and definitely worth the money if you have those requirements. It is still in the group of relational DBMS, although it's a very specialized one. AlloyDB, likewise, we have a course on that coming up. It combines row store and column store all in one system, and it kind of automatically chooses which one to use depending on your query. It's really very clever, and there's nothing else equivalent that I'm aware of anywhere else in one system. Normally, we would have to combine a column store and a row store somehow, and have some logic to figure out which one to use, and that. So it is still a relational DBMS, but it has this unique capability of doing both transaction workloads and also analytic workloads using the column store. So transactions go to the row store, and analytic queries go to the column store. So it's very interesting. We'll have a course on that. So those are the bolded ones, are all the ones that we cover in the learning path. I put BigQuery here, though, even though, as we've mentioned, it is not considered a database by Google, oddly. It is at its core, it is a relational DBMS, but Google calls it an enterprise data warehouse, and they group it with the analytic products. And so it is not covered in this learning path. It's covered very heavily in the data engineer learning path, which is a related but completely separate learning path from the one we're on. Okay, so it's used for analytical queries, and it has a massively parallel processing architecture, as do these other systems that I mentioned on premises. So there's Vertica, Yellowbrick, Teradata on premises, and then in the cloud we have Redshift and Microsoft Synapse and others, quite a few others actually, that exist in the cloud that compete with BigQuery. So I won't say more about that because it's not really specifically part of this learning path. Now, the other one that is covered in our, now I move to the NoSQL type store. So these are no longer relational here. And Bigtable is the canonical NoSQL data store within Google Cloud. It is comparable to HBase. On premises, you could run HBase, and it in fact has the same APIs, has very high read and write rates, and simultaneously high reading and writing. It's very powerful for that use case. As a type, it's called either key value. It's a key value data store, which is a type of NoSQL data store, and within that, it's subdivided further into a column family. And we'll explain what that means in next week. We'll go into what column family means, and very specifically how you use Bigtable and what the use cases for it are. Just for today, I want to call out, do not mix up the term column family and columnar data storage. These are very different concepts. It's unfortunate that the words are so similar, but they're completely different concepts. Columnar data storage is what's used in BigQuery and other analytic database systems. It means that instead of storing all the data from one row in a table adjacent to each other, we take all of the column values, all the values from one column, and store them close together so that we can enable more efficient compression, and we can also get much better performance on certain types of queries, in particular analytic queries. That's why this storage pattern is used in analytic databases. It is completely different from the idea of column family, or sometimes called wide column database, which is a subset of key value NoSQL data store. I will go into this more next week, but just for today, please don't mix these up, because you will just be calling yourself out as a rookie if you make that mistake. And it's a trap that you shouldn't fall into. Now, there are two other Google products here that are quite interesting, called Firestore and Memory Store. We don't cover them in our learning path here. Memory Store, I don't think, is all that difficult to grasp what it does. It's an in-memory cache. You can read about how that works in the NoSQL Distilled book. They have a very nice coverage of, I think, Reddit's. It could be one of the other of these. I forget which is covered in the book. but they're very similar to each other and they serve the same purpose. It's fairly easy to get what they do. And there may be a couple of questions on the exam, even though it's not covered in our learning path here. Now, Firestore, I'm pretty sure will have a couple of questions on the exam. It is not covered in our learning path, and it's a very significant product within Google. And I will bring some supplemental material into one of our later sessions to talk about Firestore, because it's comparable in a way to, so it's a document store. And what is a document store means that we can store things like JSON files and XML files within the database, but not just simply dump them in there as strings. We can also search on the contents of those documents by looking for certain, like a certain XML path. You can query, find me all of the previous addresses where this person has lived. That would be stored somewhere in a XML path, and you could write a query that would find that within the XML that you've stored in the database. So in other words, you're not just having to pull the XML out as a string and then parse it and figure it out on your own. The database gives you a lot of support for working with the particular fields within JSON and XML stored data. That's the definition of a document store, actually. And so Firestore is a very important one that has very high performance characteristics, and we'll have a little bit of coverage on that, even though there might be some labs. I can check to see, once you have access to SkillsBoost, you can run labs that are not the prescribed ones that are part of our learning path. You're free to go and search within SkillsBoost and find, I'm sure there are Firestore data labs in SkillsBoost. I will call those out when we get to that discussion, and you can definitely do that separate outside of the prescribed number of courses that we have here. Now, at the bottom here, I've grouped in a few of the significant products that are available in the Google Marketplace. They are not Google-built products. And the one that I say that I think is the biggest miss from having one of everything available to pick from is the graph databases here, the Neo4j and TigerGraph. They're both available as marketplace products. Neo4j is probably the most popular graph database. I think TigerGraph is very scalable and has a very high performance. Neo4j is the one that I've heard of much more than the others, but graph databases are useful for use cases where you're looking at networks, like a social network can be modeled very effectively as a graph. And in other words, the connections that you make within LinkedIn, for example, that really is a graph. If you draw it out, it's really nodes and edges, and that's what a graph is in this context. And that's what these graph databases are really good at working with. And they are very quick to find the relationships. They're very quick to look up, for example, my connections that I have within LinkedIn. And so that data could also be stored in a relational database, but the queries would probably be much slower and possibly more difficult. So that's where graph databases excel. They're also being used in many cases to build knowledge graphs, which have a lot of relevance in generative AI. We don't go into that in this particular learning path, but that's another use for a possible use for graph database. So those you would find in the Google Marketplace, and of course many others as well. So that's the big picture overview. Now I give you the Sketchnote here from many of you probably already know about Priyanka Vergadia. She creates a lot of these Sketchnotes, and she's got a lot of YouTube recordings, and she's just a wonderfully pleasant teacher, and just really puts a lot of these things together. So when you grab the slides, these green colored things are links, so you can go you can open these links up and find this original of this Sketchnote. And then there's also the Google Cloud documentation itself has also a listing of the databases and some advice on choosing the right database for your use case, okay? And so a lot of what we've talked about here, these are the products that we just went through. You now know at least a little bit about every one of these, right? And the one that's missing really from our learning path is Memory Store and Firestore, or Firestore. And this tells you what it's good for. And Firestore is used with web and mobile app. And so it's very big with, let's say, Flutter developers, people like that use Firestore all the time. And it's good for gamers and player profiles and retail catalog, point of sales, that kind of thing. And what's really very special about Firestore is that it's good for, if you have an app that you might be using on multiple devices, let's say you log in with both your phone and your laptop at the same time. If you make an update on one side, Firestore has a lot of capability to push that update over to your laptop. So that it's very good at keeping all of your different devices in sync. That's really its main strength over all the other products here. So I won't say too much more about this. This would be, if anyone has questions about these, mapping the use case to the different products, maybe that would be a good topic to bring up next week during the Q&A period, or maybe at the end of this session in the Q&A period. But I don't want to go through, it would take us probably too long to go through all of these right now. And I think we've talked about, as we've gone through each individual product, we've mentioned some of the use cases that they're good for. So we'll continue to do that as well, one by one. But I don't want to go through the whole panel here right at this moment. So I want to pivot now to what are the properties of relational databases and where do they come from historically? And the key point of relational database is that it provides ACID transactions, and it has primary keys and foreign keys, and the data is structured in tables, right? In tables that are all. So we talk about entities and attributes. So in a relational table, all of the attributes in that table relate directly to that entity, right? And so if not, we split it out into separate tables. And so this is where the advantage of doing that is that we have a lot of flexibility in answering queries, including queries that we haven't thought of when we're at design time, right? So we lay out the table structure and design our tables in such a way that is very flexible. The real point of it is to minimize what we call update anomalies, right? So compared to older database systems that existed before 1980, those systems had a lot of problems in two areas. First of all, you had to know the query writer or the query developer or the database developer had to know the exact physical layout of the data on the disks that were being used. And so you had to actually kind of like navigate down through a path, and somewhat like navigating an XML file. You have to know exactly the path to follow. And that is much less convenient than what we have today. With relational databases, we can use SQL, which is a declarative language. And with SQL, we just specify what we want, but we don't have to know where it is. We don't know the storage details at all. We just can specify, I want the first name and the last name from the customer table, and I don't know where that data is, but go find it for me and give it back to me. Now, the disadvantage of having these very highly normalized data models is that we usually have to do joins to get interesting results back, and that's part of what's involved in learning SQL and learning about data modeling. I think these two skills go together. I think it's really useful to know something about data modeling if you are a SQL developer or a report writer. I think it's very important to have an idea about what is involved in normalization. And I think conversely, there are, for data architects whose job it is to design tables and lay out databases, it's really useful for them to know SQL and know some of the problems that, particularly performance problems that you can run into when writing SQL queries. And I find it relatively unusual for people in the industry to have skills on both sides of that divide. There's usually, data architects don't usually know much about writing code, interestingly, and a lot of SQL developers don't know much about data modeling. And I think it's to everyone's benefit to learn a little bit of both sides of that. So I can take more questions about this, but in the time that we have, I cannot go into, I'll just say briefly what ACID transactions are, but we won't have time to go through like a whole full-length discussion about what is meant by normalization, what is, you know, what are all the design. In other words, I can't go through, I can't present a whole course here on how to design a database. I'll give some references certainly and some books and some pointers, but we can't go into a lot of depth on it. But let me just cover these top two bullets here. So ACID transactions mean that, again, I won't go through the acronym, but the basic idea is that a transaction is either committed completely or it is rolled back. And so let me give you an example. The classic example is in banking. If you do a transfer from your savings account to your checking account, the first thing that let's say the ATM has some code that's executing that transaction on your behalf, right? So the ATM first has to check, okay, you've requested $50 to be moved over. Well, does your savings account have $50 first? That's the first question. If it does, yes, then withdraw the $50, hold that thought in memory for a moment, and then deposit that $50 into the checking account, and then wrap it all up and say, okay, I'm done. Now, the issue happens when, if you didn't have solid transaction controls that we get with relational databases, what could happen is that, okay, I removed you had $50 in your savings, I removed it, I'm holding that in memory, and then for some reason the network fails at that precise instant, or a server crashes. So now you've deducted from savings, but you haven't completed the transfer to checking. So the bank has effectively lost money somehow, or lost the awareness of that money, and you've lost $50 in the process. So that's not a good outcome for anybody. What we do, therefore, is so that the thing is, the two operations are two separate SQL commands, right? Because one is a update your balance on your savings. So decrement that by 50. That's one transaction against one table. And then increment the checking by 50. That's a second operation, a second statement on a second table. So what we do is we wrap that whole thing in a transaction, and we say, if any part of this fails, we roll the whole thing back and go back to the prior state as if nothing happened before you even stepped up to the ATM, right? Goes back to that earlier state. If both of those statements succeed, then we can commit them both at the same time, and then everything is fine because we do that as one consolidated operation. That's what a transaction is. The other, so that's really the gist of what ACID transactions provide for us. You can go through and break down the acronym into its letter, into its words rather than the letters, and you can understand more details about each of those properties, but that's the gist of it right there. Now, the primary and foreign keys have to do with, primary key is to enforce uniqueness. Basically, it means that if I have an ID for, let's say, customer, I have a customer database, and I have an ID, I cannot insert a second customer with the exact same ID. And that ID could be a synthetic number, could be customer number that's generated internally, or it could be some combination of the customer data, like first name, last name, date of birth, and maybe something else, because that's not always unique, right? So you could actually, you could use that to enforce uniqueness, but primary keys don't let you have more than one of the one, more than one copy of the entity in that table. Okay, and then the foreign keys are such that, let's give you an example of that. If you have a, let's say you have customers and orders, and someone places an order, and you want to insert that order into the orders table, and you want to attach the customer ID to that. The idea of a foreign key says that I can only insert a customer ID into the orders table if it already exists in the customer table, right? I can't create a new customer ID on the fly if it doesn't already exist in the customer table. So by enforcing this at the database level, we have a lot more data integrity, because it's really the enforcement of business rules, of sensible business rules. And if we didn't have the database supporting us in this, we would have to put all this in the application code. And if you have a team of developers, maybe some of them will get it right, some of them may not get it right. So it becomes very difficult to enforce it in code if it's not enforced in the database. So that's what we call that declarative relational integrity. So relational integrity is what the situation I described, where you check the existence first before you allow another table to be written. And then the declarative aspect is, again, I just have to have a pointer from one table to another. I don't have to know anything about where the data is actually stored. So another property of relational databases today is that they almost all of them use SQL. They may have other interfaces as well, but almost every relational database has a SQL interface. That was not true in the beginning. There were actually other query languages that were competing to become initially the de facto standard, and then eventually SQL won out over all the others. And some people were not happy with that, including Ted Codd, who created the relational model. He found that SQL had a lot of flaws in it, but we've learned to live with those, and so it is the standard today. It's an ISO standard, very importantly, ANSI and ISO standard, and most vendors claim to support some version, of an ANSI standard SQL, but almost every vendor has some extension. So we call these dialects of SQL. Another characteristic of relational databases is that it's much easier to scale up. If you need more power, more processing power, more queries per second, it's much easier to scale up with the software, essentially using the same software, but on a more powerful system. We still have one set of disks, and we call that a shared disk architecture. And so you can have clusters of computers, like clusters of servers, but they typically all operate on the same shared disks, set of disks. And so that would be an example. That would be Oracle RAC, which is real application clusters. SQL Server also has, Microsoft SQL Server has for a long time had clustered servers, but they're still operating on one set of disks. As we've talked about a couple weeks ago, Postgres and other systems have replication that can be to another server in a different availability zone or a different region in the cloud, and that can be either synchronous or asynchronous replication. So we went through this before where we said, okay, the synchronous replication is more reliable in terms of not losing data in when these very unusual events happen, like a crash in the middle of a transaction. The synchronous replication is going to be more robust toward that type of situation, but at the expense of being slower for every update. Okay, so that's the trade-off. We went through that trade-off before. There was a quiz question last week. One of the sample questions brought up, I think two of them actually mentioned multi-master replication. We weren't sure how real that was. It is a real thing on both SQL, it's a real thing on MySQL, at least on MySQL and Postgres, both have something called multi-master replication, but I saw many Stack Overflow and similar reports that these things are pretty problematic. They're hard to get them working right, and there are some vendors that sell specialized products. And so I didn't have time to go back and review our sample questions. Maybe we'll try to do that for next week. We'll have that prepared to address that specific question that had the multi-master point in there. I don't know if that was the right answer or not at this point, but I would suggest that if you're considering that you need multi-master replication in order to get a higher performance of writes per second, so it's queries is not quite the right word, it's really writing is what drives you toward that, because we can have usually we can have a number of read replicas, and that's usually enough to satisfy queries. Read queries can be satisfied with read replicas. It's the writing that causes the bottleneck, and that would tend to have us go towards multi-master replication. If that's really a serious problem for you and you have the scale and the budget for it, I would consider looking at Spanner. And we'll look up that question from last week and see where this falls. But I just want to say that it does exist, but there's a lot of hate mail on it for on Stack Overflow and elsewhere. So I wanted to give a little very text-heavy slide. I'm not going to go through the whole thing, but it's here in the notes for you to check later if you're interested. I wanted to call out the importance of Edgar Codd, who worked for IBM, also known as Ted Codd. He's the one that came up with the relational theory and the normalization theory, and it's based very solidly on mathematical set theory, and that's the key to its longevity, and it's why we have certain properties that are very important to the way databases work, and those things are really fundamental to everything. So one example, for example, is there's this idea of that tables, or more formally, they're called relations, right? Relations follow certain algebraic properties. So, for example, any query that you can do on a set of tables results in something that looks like a table itself and can be stored back into a new table. And so that is a property that we have from simple, that we learned in grade school about the way numbers work. If you add two integers together, you get another integer. And that property is called closure, right? So database tables have that property, and this is based very solidly on mathematical theory that Cod worked out in the 70s. So that's the key to why it works so well. That's a lot. We give up a lot of those things when we go to so-called NoSQL stores, right? But we'll save that part of the conversation for later. But as I mentioned, the real reason for normalizing tables and separating data out into the groups the way we do it is to minimize update anomalies. And if you had, prior to the 70s, we would store data in a way that's kind of similar to what a lot of us do naively in spreadsheets, right? If you have, like, let's say you had a tennis club that you were building a little spreadsheet for, and you wanted to just keep track of people's name, address, phone number, and which meetings they had attended. If you started putting all that in a spreadsheet, you would find over time that maybe you would have multiple rows, or maybe you would add a new column for every meeting event that happened. It's, no matter how you do it, it's kind of messy. And then after a while, you would find situations where, let's say somebody moved and you wanted to record the new address. You might find that you have to record that new address in multiple places. And that's what leads to, very frequently, to update anomalies. And if you have a large, complicated database and you put the onus on the developers of code that are writing update and delete code against that database, there's a lot of ways for things to go wrong. You could accidentally delete data that you didn't want to delete, or you could do partial updates in some rows and not in others. And so the basic idea is, if you store something twice, you potentially have the problem of needing to reconcile all the locations where you've stored that data, or even finding all the locations can be a challenge. So a lot of what normalization does is enforce the rule of, I'm only going to store this data element in one place, and therefore it can be right or wrong. Hopefully it's right, but at least it won't be inconsistent, okay? I'm getting my 7 o'clock alarm, so I will be mindful of the remaining time so that we get done before 8, since we ran over 1 week and we don't want to do that too often. So the way we did, the tables are designed, and the sort of quick version of it is captured in this idea, a table, all the attributes in a table depend on the key, the whole key, and nothing but the key. And that's obviously taken from, the courtroom situation, but that is the kind of basic idea of normalization. Again, we don't have enough time to go through all of it, but we can discuss it in some of the Q&A if we have time. The relational database does not require the use of SQL as the query language, although SQL is the most common today. And the reason I bring this out is because many people use the word SQL to mean Microsoft SQL Server. Completely not the right idea, okay? Microsoft SQL Server is a wonderful product, but it is a database product from Microsoft. SQL is a language. So, I hear people all the time, oh, I'm just going to store it in SQL. Meaning what? Meaning Microsoft SQL Server. Okay. But that's really it's a misnomer that, to me, represents unclear thinking, and it's just something I don't like to see. Just like before when I said columnar storage is not the same as a column family database, completely different don't mix them up because they're completely different concepts. The same thing is here. SQL, SQL, it's most correctly pronounced SQL. Most people just call it SQL. It's a language. It is not a database product, okay? Just sorry to go on at length, but there you go. It's the point of this thing here is that 2 points. It took a very long time throughout all of the 1970s before this theory was completely accepted, even within IBM and also outside of IBM. IBM was actually slow to bring their first relational database products to market. They finally came out, I think, with BS12, which I don't think exists anymore, as far as I know. I've never heard of it until I did the research for this slide. That came out in 1982. IBM DB2 came out in 83. That's obviously a very widely used product on IBM mainframes, and that's still going strong today, and it's used in data warehousing a lot as well. But look when these products came out. You know, Digital had a very significant database product in 1984. Oracle came out with its version 2, which was its first version, in 1979. It took a long time for this to get going into commercial implementations. Now, the other point I want to make here is that Ingress was a research project at UC Berkeley in the 70s through halfway through the 80s by Michael Stonebraker and I forgot Wong's first name. Initially used the language Quell as a query language, and then some commercial versions of that came out in 1980. Now, Stonebraker, I want to call out as being one of the most important people, you know, along with Cod, who came up with the relational theory. Stonebraker was very important in doing the research at universities and also commercializing products to bring them to market. And so he went back and forth to companies and then back to UC Berkeley. And when he came back to Berkeley, he started Postgres, meaning post-ingress, right, after ingress. And later that became PostgreSQL. And that work started in the mid-80s at Berkeley. Now, let me go on with that. Stonebraker is such an important figure in this world. He, as I mentioned, was at Berkeley. He's now a professor at MIT. So he lives in the Boston area, of course. I've met him a few times. He's a wonderful person, very approachable. You can just talk to him like he's a normal human being. And considering all the things that he's done, it's amazing that he's so approachable. There is Postgres, I'm going to say more about in a minute. That was started at UC Berkeley. By the way, that's University of California for those, if I'm not saying that correctly. It's University of California, Berkeley. After he moved to the East Coast, he began a whole series of very specialized data products, including these mentioned here, Vertica, VaultDB, and Streambase, and SciDB, and some others. And most of these turned into companies. Vertica is especially important because it was based on research done with graduate students and Stonebraker together, and that there's this paper called the C-Store paper. C-Store meaning column store. That became the basis for the Vertica product, which was the first massively parallel processing analytic database system that used columnar storage, okay? Columnar storage is now the standard for every other similar system. So that alone has been enormously influential in the field of analytics, right? And so Stonebraker won the Turing Award in 2014, and this book came out a few years ago to sort of commemorate that award, and then also has writings about him and the influence of his papers and research on the whole field. I go on because, oh, there's one more thing. If you want to know more about the history of databases, not just relational, but all databases, there's a great lecture series. I haven't watched these. They're fairly new. I just found these last week. They're all put onto YouTube. There's a link there to the playlist right there. Andy Pavlo is a professor at Carnegie Mellon University, and he was also got his Ph.D. at Brown, and was associated also with Stonebraker as one of his thesis advisors. So again, there's been an incredible renaissance of database research in the Northeast and elsewhere in the world, and so much of it is attributable to the small group of people here. And I've had the pleasure of meeting some of them, and I highly recommend these recordings if you want to dig deep into all this stuff. Okay. I think I just want to say one more thing about Postgres itself. In about 2000, the year 2000, we had the interesting phenomenon that MySQL was much more popular as an open source database than PostgreSQL. I call it Postgres, right? So it's either, the official name is, I think, PostgreSQL, something like that. And some people call it Postgre for some reason. I call it Postgres, right? And that is, Postgres is actually an officially recognized alternate spelling of the PostgreSQL. So either one is fine. But around 2000, Postgres had a reputation being slow and maybe buggy, and was much less popular than MySQL. MySQL had come from a completely different background. It was not developed by academics, not a result of research, really. It was very pragmatic to solve certain problems and certain use cases. It really was missing a lot of features, including transactions and foreign keys, which are critical to many database applications. And that's how it achieved very high performance. So it was very popular in many settings. And after a while, Postgres actually became more reliable, better established as an open source product, and eventually added many more features because it was used in a lot of research settings, and it was open source for many years. It's now collected around it a group of open source communities that have really added a lot more to it. And so it's also the foundation for a lot of other open source and closed source products in the marketplace. Like, for example, Vertica has, if you log into Vertica, it's very similar to Postgres, right? The catalog is the same, the way users and groups are set up and permissions are the same as Postgres. And there are things, some of the features of storage are similar, a lot are different because Vertica is a massively parallel query engine, but it's very different. But a lot of it is based on Postgres features, and it works in some ways very similar. The same is true of Netezza. The same is true of Amazon AWS Redshift. Several others products have been based on parts of Postgres are in there, and they've changed the query engine, the storage layers a lot to accommodate the analytic workloads. But Postgres had very, very, very powerful influence on a lot of other products downstream. And it's very viable today, and you've worked with it in Cloud SQL, and it's just really has a very wide range of features available in it, and including pgvector now, which is used in Gen AI applications and so forth. So very interesting, very powerful product, and I just wanted to bring out the remarkable achievements of Michael Stonebraker to do a lot of this work. Now, I'm pivoting to another topic now, which is how do we work with relational databases? And I want to give a couple of show you some tools that I found to be pretty useful. And so remember a couple weeks ago we talked about data-related job roles. I've split the slide now. I just want to talk about the top three, which are, DBA, database administrator, data architect, or database developer, or report writer, or SQL developer, that type of thing. So what kind of tools would you use if you're working with Postgres in the cloud or MySQL in the cloud, or it could be an on-premises database as well? So for Postgres, we have, I'm staying with Postgres on these tools because, again, as I just mentioned, to me, it's the premier open source system, database system, and it has attracted a very large following of other open source communities. So a lot of other people create open source projects that work with open source Postgres. And these are the ones that I'm highlighting today. So bundled with, when you download Postgres to install locally on an on-premises system, you get something called PgAdmin. And so this is a database administration tool. I don't know how well you can see this, but these graphs are telling you the performance of your instance or your database instance, telling you, like, this is my laptop, so it's not a very active database. But it shows you the number of database sessions, the transactions per second, so tuples is another word for rows in tables, and it shows you how many inserts, updates, deletes are going on. So if you're managing an active database that is possibly resource constrained, this dashboard would tell you what's going on and would give you a way to manage that, or possibly know where you need to expand the system. So that's PgAdmin. Comes bundled. I don't know if it's developed by the same team, but it's typically bundled when you download the Postgres server. You get also the client tools, which is the command line tool, PSQL, that we've used a bit in the labs. And then also you get this PgAdmin that you can install. So that's how it looks on a Windows machine. I'm going to pivot now to the next tool. So I don't want to say too much more about the DBA tools. They're there if you need them. I want to pivot now for a database developer tool or something that would help you write SQL. This one that's very popular is called DBeaver, I think, if I'm pronouncing that. I don't know what the official pronunciation is, but obviously they're going for the DB database and then Beaver because it's a cute furry animal. And so there is a paid version of this and also a free community version. What's really impressive about this is that it's written in Java, so these connectors are JDBC drivers for connecting to a variety of database systems, meaning both relational, non-relational. You can connect to flat files somewhere in here. There's a way to use files and CSV files and spreadsheets as you can write SQL queries against these things. So the number of these is almost 100. And a lot of these are database products that you would recognize. Some are things that you wouldn't necessarily know are even out there, right? So a lot of them are the ones, all the ones that we mentioned are here, I think. It's really impressive that it can be used to connect to any of these. And most of these drivers are automatically installed and downloaded when you just click and set up a connection and says, hey, you don't have this JDBC driver, you want me to go get it for you? And it knows where to find it. And, you know, that's just really nice feature to have, because otherwise it could take you 20 minutes or half an hour to find it, download it, put it somewhere, install it yourself. It's just, you know, it's not like that big a deal, but it's just, especially if you're working with multiple database products, it just saves you a bunch of time. And so that's really the key selling point of this. First of all, it's free. It's cross-platform, so it runs, pretty sure it runs the same on Linux, Windows, and Mac, all three. So it's open source, free, and cross-platform, and you learn one interface, you learn one tool, and you can work with it with almost 100 different products. Now, the downside is that it's, let's say for BigQuery, Google BigQuery, it is not going to have support for every feature in BigQuery. So for example, it doesn't display nested repeated fields as well as the Google console does, because the Google Cloud Console is specifically designed to handle that kind of data in BigQuery. I don't think this will do, at least the last time I ran this, it didn't do that too well. So if you wanted to actually look inside your nested repeated fields, you would have to unwind them or flatten that out, or you'd have to have some idea what was in there before you went to that effort. So that's the downside of having a generic tool. But if I had to pick one, this would probably be the one that I think is most popular. There's also Pro version and so forth. So how do we use this? Well, let me say a word about what do we want to use it for, first of all. And I talk about database coding paradigms here, which comes down to really deciding where do you want to have your business logic. A lot of code was developed early on in the client server era in the 90s, going into the 2000s. A lot of business logic was put into stored procedures and user-defined functions. The advantages of this are obvious. You have tightly governed, consistent data access. Performance can be really optimized really well because network traffic is reduced with stored procedures. You have temp tables, cursors, indexes, multi-step transactions, and pipelining all available to you to really enhance performance. And by having stored procedures, it's easy to enforce versioning and testing and rigorous software engineering practices. And when you go to, more recently, it's become fairly popular to say, well, I don't want all my business logic wrapped up in my database. You know, I want to be able to like change vendors or move to different database. I don't want to develop stored procedures that are tied to that particular dialect of SQL and so forth. So I'm going to put my application, I'm going to put all my business logic in my application layer code using scripting languages. I'll get faster turnaround, faster development. I might use an ORM, an object relational mapper, if I have a website that uses object-oriented approach to present internally. It could use JSON files, things like that. I could use an ORM to ease the burden of working with normalized tables so that I don't have to figure out all the SQL by myself. And the downside of this approach is that it's I think it requires more discipline to make sure that you have actually consistent data access patterns across a whole team of developers. So it's easier to write bad code, I think, in this latter scenario. But that is kind of the more popular approach these days, I think, than using a lot of stored procedures. So I'm going to try to do a live demo here. I don't know if this will work. Let me see if it. If it doesn't work, we'll do something else. So I think what I need to do is I have and so I'm running this on a it's a remote desktop situation. So have it opened over here. So I have a remote desktop that has a Postgres server, and I'm also running DBeaver over there just to show you how it works. And so what it lets you do is, I have several other databases that I've worked with, but the one I have here is Postgres. Hopefully this will work. Yeah, it looks like it's
right now. We see the slides.
I see. Yeah, I see that I'm not displaying the. I need to move that up here, or do I? That's interesting. That's a sharing problem. Let me see how to fix that. I'm going to stop sharing and then reshare. Yeah, I'm not sure why I need to do that, but that's what's for you. So this is my remote desktop to the other machine. You should be seeing that now, right? Okay. So basic idea is that you can come in here. So this is not really the best tool for heavy database administration. The one that I showed you earlier has like the I/O traffic, the number of queries per second, all that stuff. This doesn't show you that, but this is more helpful for, it has a little bit of that under system info, I think. But what it really is for is like navigating your databases. And then I know I have a database called demo. Inside there, I have a schema called bookings, and that has my tables within that have this flight demo database here. So there's information here about aircraft, airports. I don't think it doesn't really have a customer table, but it has tickets. So there'd be like a customer ID on there. So let's just look at that. So let's say I want to look at that. I don't know what that's in that ticket table. So I just double click that. It opens it up here. I can show me some data in there. It's going to give you like a preview. Let me see if I can make that bigger. Yeah, there we go. It lets me preview that data. Yeah, there's a passenger ID, which is some kind of a generated number. I don't know where that comes from, but also has passenger name. So it doesn't have a specifically called out as a customer table, but the customer data is just rolled into the tickets table. So this is a demo database. I forgot to put the link in the slide, but I'll add the slide. I'll add one more slide showing you the link back to this if you ever want to try out this booking schema. So that's what this is good for. And then the other thing you could do is just, you can write SQL here as well. So you can open a SQL console, and you can just do like select count star from bookings dot, let me say airport. It should give me, earlier was giving me some code completion. It's not doing that right now. It was kind of helping me write the query by giving me the rest of the table names. So there, I've written that query. I can just execute that right here. And I got some kind of a typo somewhere. Airports data, that doesn't seem like that's wrong. But anyway, I don't want to debug this, but you get the idea that let me try one more quickly. Yeah, I'm doing something slightly wrong. I had this working earlier, so that's why we had the bomb on the live demo. So that's probably all I want to show you from this. Let me go back to my slides. Okay, I guess I stop sharing again and then reshare. Okay. I'm sorry, this is harder to do than I was expecting. I don't see my share button right now. There it goes. Okay. Share screen. Let's go back to slideshow. Oh, I see. I can share entire screen. That's what I want to do. Let's see. I think that'll work better. Okay, so we're back to the slides now. And anyway, so that just gives you the idea that if you want one tool to work with many databases, that's not a bad place to start. Okay, there are commercial tools that cost in the range hundreds to a couple $1,000s. They're quite good also. They're better, honestly, than this. They tend to support more features of each particular database, but I don't think I've seen one that has 100 different drivers available. So there are some advantages there. The next tool I want to mention is called pgModeler for the database architect. Okay, and this is a nice open source project that these are live links here in green, so you can go and review the open source code, open source product here. Here's the developer. Seems to be a perfectly reasonable developer for this project. He's been doing this for many years. I've watched this for a few years. What's interesting is it's open source, but you have to build it yourself. And so on Windows, that's fairly difficult to do because most of us don't have C compilers on Windows. It's not part of the standard part of the operating system. And therefore, I made a Linux machine. Last week, I actually had an old laptop that I was about to throw out, and I said, well, maybe I'll turn that into Linux machine and see if I can get this pgModeler to work. And I found some instructions that very specifically told me, here's how you build pgModeler on Linux Mint. And so I said, all right, I'll try that. It just reminded me of how much toil is involved in installing an operating system. I've been working in the cloud for 7 years, and I've really forgotten, like, I can spin up a VM in 35 seconds, right? Or I can spend half a day like building a Linux system and installing this and that and the other and getting all the compiler and everything to work and whatever. I finally got it to work, and it's quite nice actually. And let me, if I do another demo, let me show you how that one works. Let me see if I think I had, yeah, I wanted to talk a little bit first. The data modeling theory. Again, I like books. I read a lot of books, and I would recommend these very highly. The one on the left here is an old book, but it talks very clearly about the difference between logical design and physical database design. And in particular, it teaches you how to gather requirements and build a logical data model. It's very, very good for this. And I don't know of a book that I like better than this one for that particular bit of learning that's covered in this book. It's It's quite old, but it's kind of a classic in my view. It's available as used copy on Amazon for like $4, right? So it was very widely published, popular book for a while. It's now you can get a used copy for very, very low money. I definitely recommend that one. I would say if you want to learn about data modeling and normalization, don't break your head on the very sophisticated theoretical books and very academic books. There are many of those out there that start with conceptual models and semantic models and all very complex stuff that is going to require a big commitment if you want to learn all that stuff. I would recommend this book here, Data Modeling Made Simple, right? It's very practical. It's a good place to start. If you need more later, then you can do the other stuff later, but this is a good one to start. In particular, Techniques publication is run by Steve Hoberman. He's also the author of this. A very good publishing company for database books. He's got a very large catalog. I definitely recommend that you look into that. Another direction that some people have gone is to use, instead of using the traditional notations that I'm going to show you in a moment, UML can also be used for data modeling, right? To show the relationships between tables, you can use UML diagrams. My friend and colleague Norman Doust wrote this book a few years back. He's now retired, and I haven't seen him recently. He used to run the Dama New England chapter up here in Boston for many years, so he was very well known in the Boston area and wrote this book on how to use UML, also published by Techniques. So really good set of books here. I mentioned a couple of others in a minute as well. So we recognize 3 levels of data model called conceptual, logical, and physical. The conceptual, I would say, is not done very often. It's a very early stage of business analysis when you're doing the requirements gathering. You're just trying to identify entities and really getting a handle on what's going on, what kind of data you need to store, what do you need to store data about, what kind of business transactions are you trying to capture, that sort of thing. You're not at all concerned at that point with storage details. You've not even chosen what kind of database or what kind of storage it's going to be on. It's just you're really at the highest level of figuring out what's going on. So in particular, you may not know yet whether you need a relational database or a NoSQL data store. That's the conceptual level. Usually you get through that pretty quickly without having a formal conceptual diagram, although some companies do a very formal three-stage modeling. Don't see that very often anymore. I think it's useful to still do a logical diagram and a physical diagram. When you're doing a logical diagram, you know you've chosen like a relational database. You're going to use an RDBMS. You're now focusing on what are the entities and what are the relationships between entities, and in particular, you're looking for the cardinality of relationships, one to many, many to many, one to one, that sort of thing. You could be beginning to normalize your tables, lay out your database design as normalized, but it's not completely normalized yet. And also, you don't worry about data types at this point. Those details take care of themselves in the later stages. When you get to physical layer, you are now you're creating something that can turn into code that will generate the tables, right? You want to create DDL code that's going to create tables. You then concern yourself, obviously, with data types. Primary and foreign keys have to be defined. Everything's fully specified in great detail. And you may have to worry about performance optimization. Depending on if it's a large project, you probably need to worry about indexing relatively early. If it's a small project, you probably don't need to worry about that right away. So those are the 3 layers. A little bit more on this. The difference between logical and physical, for example, think of a university situation where students take courses. We know that when we're modeling at this logical level, we just define the student as an entity, and we know that course is also an entity. And we just think about it, that's a many-to-many relationship. And it's not, this isn't that hard to figure this out. You just look at it like this. A student takes many courses. So one student will have a relationship to several courses over here. So that's a one-to-many in that direction. And then you go the other direction. A course will have several, almost always have several students participating in that course. So that is a one course to many student relationship. In the database world, many means usually more than 2, or it could even, 2 could even mean many, right? So it's like 0, 1, many is how we count in database world. Because if you have to store something in another row, then you have to model it to accommodate those rows. And that as soon as you go up to 2, sometimes you could do a 2, you could say 0, 1, or 2. You could say, well, I'll do that as an extra column. But usually, definitely by the time you get to 3 or 4, it's becoming one-to-many. It's becoming a many relationship. So you cannot build this onto a relational database, though. You cannot, there's no way to denote a many-to-many relationship directly onto a relational database system. You have to add in an association table. And what this becomes now is sometimes this can be a physical object, like a roster is a list of, or sometimes could be called registration, but it's really a list of which students are in which course. And so for every combination of student and course, you now have a row in the roster. And you can also have, so sometimes a roster table could literally be just those ID to ID mapping, or other times it could also contain additional data like classroom ID, like the location, the schedule, things like that. But how do we look at this one now? It's one student will have several rows in the roster table, and one course will also have several rows in the roster table. So these become one-to-many and on both sides. And one row in this roster table only points to one course and to one student. That's why it's a 1 on this side and a one on that side. But so it's one-to-many. So the way to think about it, just quickly, is that you insert a association table or junction table, sometimes called, and you take the key from each side, make that the primary key of the association table, and then flip the direction of the many and put a 1 on this side. So that's the quick way to think about it. If you think it all the way through, the way I said, you can walk through it. It will make sense to you. But after with some practice, you say, okay, I have a many-to-many. I need an association table, and I know I have to flip the arrows this way. It becomes very routine to do it. And if you have a modeling tool, it's easy to do this as well inside the modeling tool. And then the modeling tool will generate the code for you to generate the tables onto the database. So you don't have to write that SQL, what we call data definition language, DDL. You don't have to write all this DDL yourself. You use the modeling tool to provide the automation for that step. So I just want to show you a couple more notations. The notation that I just showed you, and the one that I prefer, is called crow's feet. It's called it's called that because of this three part arrow here that looks like the toes on a crow's foot, I guess. And then that's supposed to signify many. If you can, these additional ones here mean one and only one, and on this side means one, two, many. You can either model that if you want to, if you know all the cardinalities and you want to model that specifically, you can. Otherwise, you can just do what I did here is you can do, well, this has it all. This one doesn't have it up here. This is many to many. You just say, well, I just wanted to note it, that it's a many to many. I don't care to know all the cardinalities at this stage. Later, you can go into, these are the cardinal. These zeros and ones have more specific meanings. The point of the crow's feet is just this symbol is so easy to understand and intuitive. I really like it a lot, and I use it whenever possible. So I call it crow's feet notation, or sometimes called Barker notation. Barker is somebody that worked for Oracle for a while. The alternative is IDEF1X, which came out of a discipline called software engineering discipline in the 1970s that was driven by military requirements. The US military had a lot of needs for software of all sorts, and they tried to standardize the proliferation of many of the languages that existed then, and they drove a lot of standardization, and this was one of the products from that. I don't really understand, I haven't taken the time to learn all these symbols. I just use the crow's feet whenever I can. You can read about all these options here on Wikipedia, and that's a live link there when you get the deck. Okay, so another notation that you'll see is, again, this is just a plain arrow. It's not a crow's feet arrow. This signifies a foreign key. This means that, and notice it's the opposite direction. Previously on the crow's feet, we had the arrow going to the right. This time the arrow is going away from the center toward the periphery. What this means is these are foreign keys. This is used only in physical modeling. It cannot be used as a logical model. And think of it this way: the foreign key is always defined on this is the child table in the middle. The child table is the one that has the many, because one parent has many children, right? And not the other way around. So again, you can walk through, the foreign key is owned by the child table, and it points to something on the parent table, what the meaning of this is that you cannot have a row in the roster table, you cannot have a student ID in the roster table that does not already exist previously in the student table. The student ID must be previously defined. Likewise, the course ID must be previously defined. When those two conditions are met, then you can create this row combining those two IDs in the roster table. That's what the foreign key does. That's the referential integrity that we're looking for. If you want to know more about this, there's a lot. Well, there's a book called DAMA DIMBOK, so Data Management Association is DAMA. DIMBOK is the Data Management Body of Knowledge. This is a very huge tome that came out in 2017. I'm not sure if it's been updated since then, possibly. It's sort of the classic way to learn about data management and databases, and they have their own certification path, and this is the way to study for their DAMA certification. But it also has a lot about normalization and these kind of foreign key definitions. So with that, I think we're ready for another demo. Hopefully this one will go a little bit smoother. I'm trying to demo pgModeler, and let's see how that one goes. So maybe I can do it directly. Oh, good. It's working a little easier this time. So I'm going to open up pgModeler. What I want to do is show you what makes a good modeling tool is the ability to do both forward engineering and reverse engineering. And the best way to use a modeling tool within your development team is to do forward engineering. In other words, I will use the modeling tool as a design aid. I will lay out my tables on this canvas, on this GUI that, think of that as a canvas, and I'm moving tables around and putting in entities and giving the attributes to those entities. I'm doing my normalization work in the modeling phase, in the design phase. Once that's good, I convert that model into a SQL script that creates those tables on the database. That's called forward engineering. Very, very few development shops do this anymore because the perception is that it's too slow, too cumbersome, and most developers don't want to wait for a data architect to do this work, and they prefer just to add tables directly to the database. And this I call design by accretion. I talked about this a few weeks ago. And remember, I brought up Gregor Hopi's idea that, do you want architects with your architecture? And the idea is you should recognize a data architecture role within your team. And this is still a best practice, but it's not used very much, unfortunately. And so what most people do is build databases by accretion, and then after a while it becomes complex and they can't understand what's there anymore on the database, and there's no source code. And so somebody says, oh, let's get a modeling tool and reverse engineer. Let's figure out what's on the database by letting the modeling tool create a diagram for us. That's called reverse engineering because I'm making the diagram from the code that exists out on the database already. So in other words, it's a kind of a backwards approach to software engineering because you're saying my source of truth for what is my source code is really what's on the database, right? What I've built on the database, that's my most correct source code. And in other words, it's not what our preferred practice would be to version control the model, create version SQL scripts from that, and deploy those to the database in a controlled way. And it requires more discipline to do it with forward engineering. It's not done very much anymore. I've been in both sides. I've been in multiple shops that have done it both ways. So with that, let me show you how I'm going to show you how reverse engineering works. I believe that's under design. So here's the thing. I didn't want to, going back to pgModeler, if you want to run it on Windows, you can buy the binary bits, or you have to basically subscription model. So it's like $10 a month for the ability to use the Windows version as a compiled version, because I don't have a C compiler on Windows. So my choice to use it would be basically to rent it as a subscription model on Windows, because even though it's open source, if I want the compiled version of it, I have to rent it. So I decided to build a Linux box for this purpose, and then I was able to build it from source code, and that, saved me $50. Cost me a couple of days of work, but it saved me $50. So I had the fun of working out how to do all this stuff. Seems to work pretty well. I want to, I'm trying to remember, and I'm not very familiar with this tool, so bear with me. I'm trying to remember how to do the reverse engineering. I think that's import. Yeah, that's right. So I want to import a database. It's found two connections, one of which is this one, and it's found within there. It's found several databases, and I know it's this demo, and then in there it's got a couple of schemas. I know I don't want the public. By the way, when you're using Postgres, don't dump everything into public schema. It'll be a mess. Create a schema for your project, like I did on this one. It's called bookings. So I want the bookings, and I'm just going to import everything that's in the booking. Actually, I don't know if I want. I only want tables, actually. I don't want the views or the sequence or the functions. I only want the tables from the booking schema, and I'll import that. And you see it does a really nice job of just creating a diagram from what's out on that database. Now, that's how a lot of shops use these tools. They just say, well, we're reverse engineering. We have something here that we built over a couple of years. We're just going to reverse engineer it so that we have the diagram so we know what we're working with. It's in my mind, it's not a best practice, but it's what's often done. Now, as very typical of these types of models, of these modeling tools, is that this isn't too bad actually, but it just piles the tables into a canvas, but it's not in a very optimal way to see what's going on. And so it, the lines are crossing. It's not really organized in a way that makes the most sense. So what I did is I made a rearranged version, and I have saved this. So I'm going to call up the say DBM as a database model file. I'm going to call up the one that I worked on over the weekend. So I'm just going to bring that one in. This one is a lot more pleasant for me to understand because I'll show you why. I have to make it smaller. Okay, there we go. So what I did is I put, you will learn to recognize, after you do this for a while, you'll see that there's a table here called ticket flights. And so flights, the heart of this database is really the flights table, but a very significant many-to-many relationship exists between flights and tickets. And this is an association table, which we can tell from two things. The name of it is ticket flights. So it gets half of its name from the right and half from the left. Ticket flights, that's the pattern we use for association tables. So also, it's in the middle, and it has a many. It has a one-to-many with the many going on to the association table on both sides. That's like a glaring, obviously blazing signal to you that this is an association table. This tickets and flights are in a many-to-many relationship. This is how we resolved. This is the fully resolved form that we can deploy to the physical database itself, and this is therefore called the association or junction table. Now, there are other kinds of relationships here where, like, there's a many. Oh, okay. Here's another good thing to call out. There are two relationships here, one-to-many relationships between airports data and flights. So why is that? Well, that turns out because we want to enforce foreign key integrity constraint. We want to do that twice. So we have two uses of, a little hard for me to read this, but we have the airport code appears twice in the flights table. It appears as the departure airport, and it appears as the arrival airport. And in both cases, we want to enforce the referential integrity and say, well, I can't make a flight. I can't enter an airport in the flight table if it doesn't previously exist in the airport's data table. And that's why we have two of these relationships that look between the two tables. It does not mean that there are two different columns. That could also be the case, but that would just be represented by one line, by one relationship. You could have two or three columns in one relationship. This means that there are two instances of two separate relationships. So that's all I want to say, but this gives you an idea. Now, if you were following best engineer practices here, you could modify this structure and then create an upgrade script to deploy onto your database. And that, that's a whole art and science unto itself. That's the way that these tools are meant to be used. So that's all I'm going to say about this one. I'm going to go back to my slides now. I don't just want to close that, so that's fine. I want to get back to my slideshow. There we go. It should be coming up there. I think we're almost at time, so I'm going to wrap up. I didn't leave time for questions, so please use the Slack channel as you have been doing. Just where we are, if we had time for questions, you could have asked about any of these topics, and those are all fair game. Let's just quickly preview. We already covered this earlier. We're working on Spanner and Bigtable. We'll try to complete those 2 courses by next week, and we'll talk more about Spanner and particularly about Bigtable, its unique features next week. And yeah, our goals for next week are to wrap up the Spanner course and the Bigtable course. This is the goodbye slide. So when you get the slide deck, you can click on this link and redeem your badge. If you haven't done that already, you'll get a badge for participating in this in Credly.